My name is Ricardo Valerdi, and I'm a professor in the Department of Systems and Industrial Engineering. In this video, I'd like to accomplish 4 things. First, I want to share with you how I got into engineering. Then, I'd like to share with you some courses that you might take if you were to major in systems engineering. Next, I'd like to share with you where some alumni from our department are working now after getting degrees here. And finally, I want to share with you a day in the life of a systems engineer from my perspective and from my own experience working in industry. The systems engineering major is one of 3 majors in the Department of Systems and Industrial Engineering, which we call the major triad. Systems engineering is one option. Industrial engineering is another. And finally, engineering management. Now, there are some similar coursework that you would take in one major or another, but there are some unique and specific characteristics of each one. Today, I will just talk about systems engineering and its unique characteristics in terms of some of the skills and courses that you would take. One of the important things to know about systems engineering is that they worry about how to define and design a system. In other words, defining is trying to articulate in writing what the system should do for the client. Designing is to take those words or those ideas and to implement them into a solution. The design part is really just the beginning of the whole life cycle though, because then you have to build it, test it, and then deploy it out in its operational environment. Now, I've mentioned the term systems a few times. Let me define what that is as well. So a system is a group of components where the whole is greater than the sum of its parts. Now let's unpack that for a moment and think about what that might mean. So the computer that you're using to watch this video is a system. A hospital is also a system. The electric grid in this country is also a system. But in a sense, the simplest system I can think of is a lead pencil. So think about what that might look like. It's got a piece of wood with some paint, some lead that runs through the middle that then gets sharpened. It's a small piece of metal that holds the eraser. So you have a number of components here which individually don't have very much value, but when you put them together into a system, the pencil becomes a reality. So together, these components become a system and become more valuable as a result of them being integrated. A system engineer thinks about these things, not just how to define them and design them, but also how to build them correctly. Now think of not just simple systems, but very complex systems. Maybe a computer system that is a server, or your handheld computer, which is your smartphone. It performs a lot of functions, but it also communicates with other systems. So your cell phone might be on the Wi-Fi network, it might be on the cellular network, and it talks to servers somewhere. Or maybe you talk to other people, or maybe you take a photo and you upload it to the cloud. So a systems engineer is thinking about how all those things tie together and can be done efficiently and effectively. There are 2 important characteristics that I think set apart a systems engineer from other parts of engineering. The first is they think about the combination of technology and people. So we don't think about these things just as individual components that are made up of hardware or software, but we actually think about how those technologies interact with the people who are building them or the people who are using them. So this is unique characteristic number one. I would say another unique characteristic is we think about the life cycle of the system. Not just from the very beginning of the idea and how you might turn that into a design, but also how you implement that design, how you test that design, and then how you deploy it or implement it in its operational environment. So we like to think of the life cycle as cradle to grave. In other words, from the idea all the way to the disposal of the system. So think about all these things that surround you and that make your life a little bit easier, a little bit more efficient, and improve your own quality of life. Those are the kinds of things that systems engineers think about in the context of the people and the technology throughout its entire life cycle. I want to give you some background about how I got interested in engineering and eventually decided the major that I was going to study. So I grew up in Southern California, in San Diego, and when I was in high school, I knew I wanted to be an engineer. First of all, my dad was an engineer, but also I was interested in gadgets. I always thought of technology as something magical. So I loved computers. I was one of those kids who would take apart things to try to see what was inside. I wouldn't necessarily put them back together all the time, but I was just fascinated by all the circuits and all the electronics inside. In fact, at the time, I used to build my own radios, microphones, just to try to experiment to see what that stuff was all about. So I knew then, going into college, I wanted to study some type of engineering. And when I learned about electrical engineering, that's the major that I chose. So the first degree that I got was a Bachelor of Science in Electrical Engineering. After graduation, I worked at Motorola, which is a company that used to make cell phones and currently still makes radios. And if you think of the police radios, the walkie-talkies that they use, or the fire engines, how they communicate, that is a specific division that I worked in. After a couple of years, I went back to grad school and I got a Master's of Science in Systems Architecting and Engineering. And that degree actually exposed me. That was the first time that I had heard of systems engineering. And I took the course, one of the first courses in that master's degree involved looking at systems from a life cycle perspective. In other words, how do you turn a client's need into a set of requirements, and then how do you take those requirements and implement them into possible solutions, and then how do you take those implementation ideas and then turn them into a design, and so on and so forth. And so that was my first exposure to systems engineering, although I had grown up as an electrical engineer. After the master's, I got a PhD in industrial and systems engineering. So this first degree was at the University of San Diego, and these other degrees were at the University of Southern California. So my PhD really exposed me to even more ideas, not just only looking at systems from an electrical standpoint, but also looking at them from a software perspective. And it's important to know that a lot of systems have hardware and software, but in a sense, a lot of the complexity comes from the interaction between those parts, the interaction between the hardware and the software. After graduating from USC, I moved to Boston and joined the faculty at MIT. And then after 6 years there, I came to the U of A. And that was about 9 years ago. And so since coming to the U of A, I've continued my research program and have honed in really on 3 things that I'm very interested in and still pursue research in. The first topic that I'm interested in is cost estimation. And why that's important for engineers is before you even start a project, you need to be able to tell, well, how much should this project cost? And can I make some predictions at the beginning before I actually start the project to try to figure out, is this something that I'm going to be able to build, that I'm going to be able to sell later and make a profit? Or am I going to ask for enough money up front to be able to pay everybody, all my developers or all my engineers, to be able to complete this with all the functionality and with all the features that the client wants? So cost estimation has always been an interesting topic for me. That's actually what I wrote my PhD dissertation on. And it's just a question, an area that is so fruitful, and it touches not just the areas of engineering, but it also touches business, law, economics, a very multidimensional topic. The second thing that I'm very interested in terms of research is decision analysis. Now, decision analysis may sound like something that is maybe part of psychology. Certainly, it draws from a lot of concepts from that area, but it's specifically tied to engineering. And you can think of engineering as a set of decisions that need to be made along the way. So it's not just using the best components from here and from there and putting them together, but it's deciding, well, how do I choose the best component? How do I choose the best combination of those two components? And that's not as easy as it sounds. So there's a lot of statistics involved in this, a lot of psychology as well. It also touches business, but ultimately we take an engineering approach to try to understand how people make decisions. And the third area that I'm interested in is sports analytics. And this is actually sort of a hobby of mine, but it's become a research area as well. Not just how to better understand sports. So if you've heard or seen the movie Moneyball or read the book Moneyball, you're probably familiar with some statistics that apply to sports. But it's also how we can use sports like baseball or basketball to better help kids understand things that might be abstract or might be difficult in say the middle school or elementary school age band. And how do we use sports then to get those kids interested in math and science as a result of being hands-on, of being active, and being able to interact with the sport in a way that makes something that might be abstract a little bit more understandable, a little bit more visual, and certainly a little bit more hands-on. So these are the 3 areas that I do research in. I also do some teaching in these areas, which I'll tell you about in just one moment. Next, I want to tell you about some typical courses that students in the systems engineering program might take. So let me start with some of the courses that I teach, and then I'll mention a longer list. So I mentioned earlier my research interest in cost estimation. So this is a course that I teach in the department, and it has to do with trying to understand how we can take data from previous projects that have been completed, use that data to build some forecasting models. Then that can then help us make some predictions about future projects. So put yourself in a situation where you're trying to plan a new project, and you're trying to figure out not just what the system or what the product might do, but also how much it might cost to build. And you are also going to be interested, or at least the person paying the bill is going to be interested in when the project will be completed. So they're looking at performance, they're looking at cost, and they're looking at schedule. And these three things have to be considered in order for the project to be successful. So the course covers all those kinds of things that a planner or that any type of engineer is going to need to determine upfront at the beginning of the project whether their project is going to be successful or not. The other course that I teach is sports analytics. And this is essentially an applied statistics course. We take ideas from baseball, basketball, football, and other sports and try to use historical data in a very similar way that cost estimation does. But we also try to use that data to then understand what some future trends might be of athlete performance, team performance, or even in some cases, the economics of the sport. So this is a set of tools from sports analytics that can also be applied to the broader business industry. So you think about if you work in a hospital and you're trying to more efficiently run that hospital, you might use some techniques from sports analytics in order to be more efficient and more effective. Or say maybe you work for an airline and you're trying to understand, well, how do we get our passengers from point A to point B, or how do we get our cargo from point A to point B, or even our airplanes or our personnel from one point to the other in the most efficient and effective way. And a lot of the things that we cover in this class help determine those solutions using statistics, using mathematics, using models. So that is really at the core of what system engineering is all about, is trying to understand what the world around us is looking like by building a model, and then using that model then to make some predictions about the future. Now, some of the other courses that might be taken in the department, we have a course called Systems Engineering, but it covers concepts from the product life cycle, okay, that I mentioned earlier, from beginning to end, from cradle to grave, or as we like to say, from lust to dust. Other courses that might be covered, sort of similar to sports analytics, but statistics is a topic that is just so broadly applicable and such an important tool set that you can apply to a lot of different problems that it's also a fundamental course in our major. We have a course on decision analysis. I mentioned this as one of my interests as well, but it's really applying statistics in order to support the area of decisions and decision making from a technical standpoint. So one of the important decisions that engineers often have to make is whether they should purchase a component or they should make it themselves. And that's an important consideration all throughout, because purchasing a component might help you do things faster, but of course it's going to cost you money because you have to pay somebody for it. Whereas making the component yourself might actually be cheaper, but it's going to take you a longer time in order to get there. So it's a trade-off that a lot of engineers often have to make. We also teach courses in software engineering, which, as you can imagine, there's software almost in all systems around us, especially complex ones, especially intelligent ones. And software becomes a fundamental building block for a lot of systems as a result. I mentioned modeling before, but there's actually a course on modeling and simulation, which is to use computers to try to understand how systems perform, how they behave, and using these tools in order to help support some of the decisions, whether they are design decisions, whether they are performance decisions. And when you think about all these tool sets, They really are fundamentally to put the systems engineer in a position to be able to orchestrate and be able to be the glue that ties that system together, to make sure they are thinking about the beginning and the end of the system lifecycle, to make sure they are considering the people and the technology and how those things tie together. I want to share with you some places where our alumni are currently working, just to give you an idea of how those courses and those tool sets that I mentioned before get translated into real marketable skills that companies want. So we have some alumni working at commercial product companies like Apple and Microsoft. And they might be involved with the product management, or they might be involved with the integration of hardware and software, or they might be involved with sales and the technology part of getting the products out the door. We also have alumni working at transportation companies like Uber and American Airlines. And again, their role might be involved with the product itself, whether it's the Uber app or the implementation of the transportation network at American Airlines and how to make it more efficient. We also have students working in some industries like agriculture with John Deere. And you might think John Deere just makes tractors, but they don't just consider that technology. Of course, John Deere is a company that helps farmers accomplish things like precision farming. So you can think of not just what is the tractor doing in a farm, but also maybe what are some of the satellite images of the farm and how is that information being used to determine where to water in an optimal way. So you can think of all the data and all the different technologies that could help farming be done more efficiently and more effectively. We also have students in the financial services industry working at companies like American Express and Capital One. And I'm sure you've seen all their commercials on TV, but when you think about all the analytics, all the data that these companies have to do about all the transactions, maybe how to detect fraud, or maybe how to protect people's information. This is really what engineers and systems engineers really can contribute to, and they can come to the table with a set of skills that can help these companies not just provide better products, but also provide better services. I want to end by sharing with you a typical day in the life of a systems engineer, just to give you an idea from my perspective at least, and from my own experience of how a systems engineer might spend their time when they're working in industry. This might vary a little bit if you're in a small company or a big company, or if you're in the commercial electronics industry or the transportation industry, but this will give you at least some insight. So say that their day might start at 8 a.m. and they might attend a design meeting. And it might be a meeting in collaboration with maybe other engineering disciplines like the mechanical engineers or the electrical engineers or the software engineers. But the discussion is at the very top level, trying to figure out how to revise the design of a product that they want to sell to a customer. Maybe from 9 to 11 a.m., the systems engineer is working on a specification. And this might be what they do to get the customer's idea into paper, not just into words, but maybe they're drawing design diagrams as well. And the specification is a very detailed description of what the system will do. So this is still in the upfront planning stages. They're working in the very early part of the life cycle, but they're bringing some of their engineering know-how and their ability to work with different engineering disciplines to integrate and come up with a solution and propose that solution to the client that hopefully will satisfy their needs. Maybe from 11 to 12, they might work on learning a new software tool. And tools are very important for engineers because they help them work in a more organized way. They help them work more efficiently and effectively. And so part of being an engineer, even when you're in industry, is being a lifelong learner. Always being open to learning new skills, learning new tools, new methodologies, so that you can bring a lot of value to the end user. Maybe they take a lunch break, and in the afternoon they prepare for a meeting with client. And this preparation is key to any effective meeting because all this work that they might do in the morning, they might have to present it in a way that is understandable to the client. Sometimes the client has very high technical expertise, but sometimes they don't. And the systems engineer often serves as the bridge between the technical side of the house and the client. And so this preparation might be something that they spend a lot of time on to make sure that they distill the concepts and they distill the ideas into the most important components so that they can have a fruitful discussion with the customer. Okay, so maybe from 2 to 3, they attend a discussion with the test engineers. So depending on the type of system somebody might be working on, the test part of the engineering lifecycle might be very important. So before you're ready to hand over the product or the system to the client, you're going to do your own internal testing. Whether it's in a laboratory or whether it's out on the field, it's going to be controlled by the developer, by the systems engineer, by the tester, and there might be a discussion about how that testing might be done. And that is obviously critical because a lot of times systems could actually harm equipment, they can harm other people, they can destroy themselves if they don't work correctly. So getting the testing right is a critical component and a critical aspect of engineering. So maybe from 3 to 5, they might analyze some test data. So this is work that now has to be done individually by the systems engineer to try to figure out how they're going to interpret the data that came out as a result of the test, how they're going to determine whether the product passed or failed the test, given certain thresholds, given certain criteria, and then how they're going to then go back and maybe modify the design, or maybe go back to the drawing board and redesign the whole thing from scratch in order for the system to pass the test and meet the customer's expectation. So this gives you a little bit of insight into what a typical systems engineer might do throughout the day. This might happen in a factory, it might happen in an office, or it might happen out in the field. It really depends on the product or service that's being provided. But this gives you at least a little bit of a look into the kinds of conversations, the kinds of interactions that occur, not just with other engineering disciplines, but with the clients and the results that are generated for that client. So I hope this video gave you a little bit of insight into the system engineering major. I hope that learning at least how I got into it gives you some idea of the different dimensions and really the interdisciplinary nature of systems engineering. I hope the insight into the courses shed some light into whether you'd be interested in this major. But the thing to remember is two things really that set systems engineers apart is that they think about the technology and the people, and they also think about the product or system throughout the entire life cycle. And so if that interests you in any way, then systems engineering might be for you. Thanks for listening, and bear down.